So we can get started. Good morning or good day, ladies and gentlemen. I hope that everybody is well and safe during these unusual times of COVID-19. As you can see, I'm recording this presentation from my home office and I wish to have the opportunity to meet all of you very soon. Please allow me to introduce myself. My name is Eduardo de Azevedo. I'm a product application specialist at Shell Global Commercial Technology, based in Hamburg, Germany. I'm also leading the development of our Shell Immersion cooling fluid for computer and data centers. And this slide is a cautionary note that reminds us to not use the information in this presentation as the base for any trading activities. I trust this is clear. Firstly, I would like to thank the OCP community and members for this opportunity to present here today. Looking at the OCP members' mission and values, it is my pleasure and honor to start working in collaboration towards a better world for our children and future generations. The world is changing to a lower carbon energy system. Shell is a large company that supplies around 3% of the energy the world uses. We want to play our part and contribute to the global effort to tackle climate change and meet the goal of the Paris Agreement. Shell's purpose is to provide more and cleaner energy as the world continues to grow. We support the energy transition via development and investment in lower carbon products and technologies. But we cannot do it alone, and that's why we partner with the immersed cooling specialist Asperitas on the development of innovative energy solutions aiming to reduce data centers' energy consumption. With the rise of digitalization, computing power is ever increasing. Data networks consumed around 260 terawatt hours globally in 2018, or about 1.1% of total global electricity demand. It is estimated this demand could rise nearly 10% in 2021. By optimizing the cooling technology, in other words, moving from air to liquid cooling, energy consumption is reduced, used more efficiently, and it allows us to use the residual heat to be reused in a sustainable way by surrounding communities. So, as part of our ambition, I would like to introduce you to our new Shell Immersion cooling fluid. Our fluid was developed and co-engineered with our strategic partner Asperitas. It is optimized for Asperitas' natural convection-driven immersion cooling solutions, but can also be used in pumped or forced circulation systems. Shell Immersion cooling fluid is a synthetic, single-phase immersion cooling fluid made from natural gas using Shell GTL gas-to-liquid technology. In this slide, you can see a brief description of the Shell's gas-to-liquid GTL technology, which basically converts natural gas into high-quality liquid products. GTL fluids have a water-white color and offer a uniform chemical structure, a high flash point and low volatility, and an outstanding light and thermal stability. The products are colorless and contain virtually no sulfur, nitrogen, or aromatics that are found normally in conventional crude oils. The GTL process consists of 3 stages. In the first stage, synthesis gas, a mixture of hydrogen and carbon monoxide is manufactured from natural gas. Impurities are removed from the syngas at this stage. The second one converts the synthesis gas into liquid hydrocarbons using a catalyst. In this stage, a liquid is formed which looks and feels like a wax at room temperature, just to give you an idea. The final stage is cracking and isomerization, which tailors the molecule chains into products with desired properties. This yields on liquids with a high level of purity and well-defined isoparaffin molecules, with which influences significantly the fluid physical properties, specifically thermodynamics. On the table above, you can see the shell immersion cooling fluid typical properties for your reference. So, associated with the high purity of GTL medicinal base oil, we specifically select the additives to ensure even higher thermal and oxidation stability during the operation. Important to mention that during the fluid development, we have considered all details and specific aspects for immersion computing application, such as materials, conditions, and the location where the modules will be installed and deployed. For us at Shell, the safety of the employees, customer, and society is the utmost priority. As the GTL synthetic base oil meets the US and European pharmacopoeia purity requirements and is food grade certified, the safety of the people handling the fluid is improved. The fluid extremely lower volatility and non-evaporating characteristics contributes not only with a safer environment, but also with sustainability and not depleting the ozone layer. Its lower density means that the fluid's lighter per cubic meters, contributing the data center's customers to save money in infrastructure and ground and foundation reinforcements for their models, comparing with other fluid technologies that could reach up to 2 times heavier per cubic meters than our fluid, or 2 times the density of our fluid. The liquid has high cooling efficiency, excellent flow behavior, as well as thermodynamic properties, and will be available across the immersion cooling market. In easy words, due to the purity of the GTL, there is nearly nothing in the oil which can react with components. Our global commercial technology and project and technology teams work together around the world, exchanging expertise and know-how among our team and our technology centers globally, specifically in Amsterdam, Hamburg, Houston, Shanghai, and Bangalore, with the highest customer centricity. We use the expertise acquired along the latest decades in formulating and producing the highest top-tier lubricants, dielectric and thermal fluids to the majority of the industry sectors. We work collaboration with our customers to overcome their challenges, taking advantage of our fluid analytical capabilities, especially when it comes to compatibility tests and fluid analysis. For example, we listed a few tests which are key to understand the fluid and equipment condition. The first one is the ICP, the inductive coupled plasma, which is an important test to determine if there is any metal or organic compound on the fluid, either coming from leaching out from the components or any possible external contamination. By identifying these elements, we can help to understand the source and monitor the trends. Another test is the FTIR, the Fourier Transform Infrared. In the example above, this graph shows the spectrum of a piece of cable over another spectrum from a database where it's possible to identify the constitution of the material and mitigate any compatibility challenges. This is very helpful where we don't know exactly the material compounds. Oxidation and acidity tests are also important to determine the fluid condition over the time. Last but not least in the slide, thermal functional tests such as specific heat, thermal conductivity, and relative permittivity are also made to understand the fluid performance. So, Finally, there are three takeaways I want you to take along today. The first one, our new shell immersion cooling fluid, is an innovative GTL-based solution for data centers. Okay. The second one, it will help us on our sustainability journey by reducing the CO2 footprint. The third one is that it leverages reduction of TCO, the total cost of operation of the customer. So, with that said, I would like to take this moment to thank you for your attention. I would be glad to answer any question during the Q&A session after the recording video session will be shown. Okay. Best regards. Stay safe and greetings from Hamburg. Bye bye.